Hey, Carolyn, how are you doing today?
Hey, what's going on, John?
Oh, not much.
Fancy meeting you here at the Future of Data Meetup.
I know. I feel like this is becoming our regular thing now.
So, welcome to everybody here joining us on the various live platforms. We're pleased that you're here tonight because we are just going to have a really fun time. I will tell you that we are streaming live on 3 different platforms, and we're streaming live, and that means that anything could happen. So it's very exciting and very scary all at the same time. So my name is Carolyn Duby, and I have with me here tonight John Kuchmick, who is my friend and colleague, a fellow solutions engineer, and newly moved to strategic region, so I'm missing him already. But anyways, we are here tonight, and we are going to have a meetup on NiFi. Now, everybody loves NiFi. NiFi is super useful. I do a lot of work in the cybersecurity space, and NiFi is really, really useful in that area. But it's just one of those kind of, like, Swiss Army knives, right? Like you can do a lot of stuff with it. But tonight we're going to try and boil everything down so that you can get started with it, right? So I started the Hello series of meetups because I wanted some meetups that were of more kind of introductory nature so that people could really get started with these technologies, because sometimes it's a little overwhelming. You see all these really cool things with NiFi, but you're like, what is NiFi? How does it work? So tonight, John is going to go through some examples with you, and he would really like to know where you're from. So I'll start off. I am from Westport, Massachusetts. It is the south coast of Massachusetts. I'm about 50 miles south of Boston. And John's going to be doing a demo, and he's going to be doing some weather things. So he wants to put in some locations. So just type in your chat there about about where you're from, and let us know your name. And if there's anything that you want to know, like if you have like a burning NiFi question that you really need to know, or if you have any ideas about future meetups, things that you'd like, topics that you'd like us to cover, anything, that you want to give us for feedback, that would be great. So I think, should we get started? Should we talk about the prizes, George? What do you think? I'm talking to George. So I just want to say that we have a fabulous crew of people behind the scenes, because without them, like, this whole thing would not happen. So we have George and Bill and Shelby, who are our social media team that help make this whole thing work. So anyways, I'm just going to tell you about the fabulous prizes that we have tonight. We've got jackets and shirts and bags, and I don't know, do we have water bottles there? Maybe some water bottles. But just like anything else, there's no such thing as free lunch, right? You have to do stuff to get the prizes. So, fortunately, it's easy. You're going to comment, ask a question in the chat. And then at the end, we'll have a raffle. And so you have to be present to win, right? So you've got to stay for the whole thing, but you're going to want to anyways, right? Because this is good stuff. So at the end, we'll be doing a raffle picker with all of the folks that have participated in the chat, and we will do that at the end of the presentation. So without further ado, I'm going to bring John back, and I think we're just about ready to get started. Here he is.
Hey, so awesome. Thanks for the introduction. For those that don't know me, my name is John Kuchmick. I run the Future of Data in Philly. So this is the Boston-Philly, joint meetup. I started actually using NiFi, I don't know, maybe 6, 7 years ago, something like that, right? I used it a bit ago. I worked at a company, the the largest publicly traded water utility in America. And when I first started using NiFi, I fell in love. So much so that I actually wanted to join this company. I'm not going to lie. So, today is all about, the 101s, the basics. So if you've never played with NiFi before, this is the one for you. If you have, maybe you'll learn a couple extra tricks. We're not going to get into the weeds too much, but I do have some demos of the flow. I want to go over everything with you right now. So I'm going to share my screen. Let me bring this up here. It's taking a second for the screen to come up from the backstage. It looks like it's backstage, but George, if you want to switch over to the dual screen so that you'll be able to see it, would really appreciate that. Oh, it looks like we're having a little bit of a screen snafu. We'll figure it out. But anyway, so while we figure out the screen snafu, I wanted to let you know, NiFi was actually started, and I do have a slide associated with this. NiFi was started in 2006. I think it was developed by the NSA. So if you think, the NSA obviously is moving tons of data along the line, NiFi. In the back end of NiFi. Today, we're going to kind of go over, this is the agenda. We're going to go over the basics. We're going to go over what building a flow looks like. We're going to go over the NiFi registry. So for those that are not familiar, the NiFi registry is a way to do CI/CD, right, in NiFi. And we're going to do then some Q&A. If there's not a lot of questions, then that's fine. We'll move directly to the demo. And if not, then what we'll end up doing is we'll actually do we'll do the demo and then Q&A continued. So we'll have to see as it goes along. It ended up moving over to Cloudera. And the NSA essentially, they donated the code base. Joe Witt spun the company off, a company called Niagara, right, which eventually then, Hortonworks acquired, and then Cloudera and Hortonworks merged. So that's why you'll see everything on our Cloudera deck. But Apache NiFi also gives you a lot of flexibility, right? So traditional ETL tools, or even, building, say, like a pipeline in Java or, Python to be able to do data ingest, what you have to do is, if you want to make a change to that, you have to stop your flow right in the middle And by stopping that flow, you essentially, you no longer are bringing data in. Well, this is actually a concern if you're streaming data in real time, right? But pulling data in a batch orientation from a database is not really a really big problem. But if I were to go back, I think in the beginning, right, I was showing some slides and I think there was a bit of an audio issue. So what I'm going to do real quick is just go back here and show the flexibility of NiFi. I shouldn't have put these things in, right? And why NiFi, right? Being able to, we look through all of this, but being able to pull data from, say, RDBMSs, being able to pull data in from like an API call, being able to pull in flat files, being able to go grab data from, message systems or, in a publish subscribe mode, all of that. And then being able to do it as fast as you want or as slow as you want, right? So if you want to do something batch oriented, or you want to do something that's incremental, or you want to do something that's in real time, NiFi will actually carry all of that for you. So let me skip ahead now, right? And we discussed, right, NiFi originally came from the NSA. There was a team from the NSA that developed it, and it eventually went open source in 2014. But, one of the things is, like, I have a daughter she just turned 13. But this summer we sat down, and what we wanted to do is we wanted to say, hey, I wanted her to start to learn how to program, right? I've been showing her coding a little bit as we go, but I said, hey, this is a really good way for you to kind of get the idea, right? An engineering mindset to be able to build things without actually having to get into, the code itself. So we bought a Raspberry Pi. We decided that she was going to stand up to Raspberry Pi, so she did. Of course, I was right next to her, right, the entire time. And the first thing that we did is we installed NiFi. And so I was like, hey, let's build our first flow. So NiFi gives you this UI template to kind of have this drag and drop design, allows you to configure these processors, right? And through that, you begin to build your flow. I firmly believe that you don't need to program to use NiFi. So it actually democratizes building pipelines, which is amazing. And I also believe that all you need really is an engineering mindset to do it the right way. So if you look, guaranteed delivery, there's a lot of aspects of NiFi, and this is why a lot of enterprises are using NiFi today. So we're going to go over some basics, right? And so here's some terminology, and I'm going to fly through these slides real quick because I just want to speak to them. So everything that we talk about in NiFi is a flow file. A flow file can be one to many records that are actually put together and will pass through what's called a processor, okay? Now, this processor, which is the next piece that we see, the processor actually, if you think about it, it's like a function, right? It's a piece of code, and all you have to do is put in those configuration parameters in that piece of code, right? And it does the thing that you want it to do. So imagine you're building, if you're in Java and you build a class, right? And you have a series of different classes or functions within the class, right? And then you have a method or an object, right, on the top end. All of these little pieces, right, of these flow files can be looked at as functions or classes, right, as you're passing the data through. And then there's the connection. So you can have inbound and outbound connections to each processor. Some processors only allow you to have outbound connections. Some only allow you to have inbound connections. And, there's a series of ways in which you can push things. You can push things into, essentially a failure queue. You can push things into a success queue. There's ways to retry processors. So there's a lot of different robustness within NiFi. And if you see here, right, then there's also a thing called a process group. And the process group is very important. So when you take an entire workflow and you've organized it together, you want to take that workflow and put it together into the process group. And the reason why you want to do that is because it allows you to then do version control over the entire process group. So if someone goes in and makes a change that has access to that, or you go in and make a change, you can actually then increase the version. And this all interacts with something called the NiFi registry. Now, the high-level capabilities. We have customers that are ingesting data, terabytes to petabytes a day of data. NiFi has awesome scalability. As a matter of fact, there's some resources. So one of our engineers, Mark Payne, who is also, one of the original guys built NiFi, Mark Payne put out something about processing 1 billion events in NiFi. So, it has scalability. You have the ability to scale out if necessary. It allows you to set back pressure through each connection. So essentially, if you had, say, one processor that you feel is going to be a bottleneck, right, as you're going through processes, you can set that back pressure to make sure that, throughout the entire, so that way you never actually come to that bottleneck. You allow things to go through in the way that you want to. It's incredibly secure. So you have SSL. We'll go through security a little bit because I do have a couple slides on security. And it's extensible, right? Meaning that you can build your own stuff. I am one who always goes in for some odd reason, and I always find a way to, use an execute script or execute stream process or execute stream command processor. And I develop, I'm primarily a Python guy, although Groovy's probably a little bit better. But I'll build something to do transforms on data sets, and I've even built custom processors, right? So if as you get better at development, right, you can actually build a custom processor. It's in Java. It's not very difficult to do. And matter of fact, it's pretty easy to take an existing processor, bring it in, and start to build on top of it. Now, NiFi works on this distributed architecture. And if you see, there's something called a primary node, and then you have a cluster coordinator, and then there's Zookeeper. So you can run NiFi on a MacBook, and I do all the time. You can run it on a Raspberry Pi, but those really aren't production grade kind of, deployments of NiFi. When you start to get into the production deployment, what you want to do is you want to make sure that you have multiple nodes. And we usually recommend 3 nodes for that. And the reason being is that 2 nodes will get you HA, but if 1 node were to fall off or something were to happen, you want to make sure that you still have HA capability left. All of this is managed through like Zookeeper, your state server, right? So Zookeeper is where all of your state gets managed. So you're going to notice, and I'm going to show you in a demo where I actually use a processor that maintains a state. Actually, I do one for a file and I do one for a database so that you can see. All of those states are held in Zookeeper. But you have the primary node and you have the coordinator node, and then you have the additional nodes as well within the cluster. By being able to cluster, what ends up happening is you can distribute the load of your data. So as the data comes in, and say you have to do some mechanisms to split the data, which you'll see I do that. And we say, try not to split if you don't have to, right? Try to use the record if you can. But in this case, I needed a split, and then I merge it back together as soon as I'm done what I need to do with it. But by doing so, I can then load balance the connection and basically distribute it across the entire cluster. So it does have an internal mechanism of load balancing. You can set the type of load balance parameters. It's pretty awesome. This visual command and control is what I love about NiFi, right? And it was what made it very easy for my daughter to start to build. And even when I was actually, building this as, at American Water, the company that I came from, it was very easy for me to show what was happening step by step. So if someone wanted to know what was happening in a flow, if you do that with Java program, they need to know code. This, you don't have to. You can say, hey, I'm getting a file, I'm routing on attribute, right? I'm doing this piece, and then I'm moving it to the next step and step. So it's very easy for people to visualize what you're doing with the data. It also handles errors very well and failures very well. So you could route the failure either back to go ahead and rerun the process again, or you can do some exception handling. So instead of having to write code, I now can write the failure off to something else so that the exception handling is well maintained. The idea of provenance and lineage to me is important. The reason why is that everyone has to deal with some sort of auditing. Auditing and controls is pretty much in every enterprise. At a minimum, SOX compliance, right? You need SOX audits to see what happened to data sets. There's all kinds of additional, auditing that occurs based upon the industry that you exist in. But the cool thing is that I can actually go through the data provenance and look at every piece one by one, right? That's actually, every transform that's happened to the data, and look at the code snippets of the data at that point in time. So, there's default values to save it on the cluster, but we used to actually offload the provenance so that we can go back and look at it in case we're ever audited, and we can replay events if we really wanted to. I think that's incredibly important, and that really sets NiFi apart from a lot of the other ETL tools, right? You can look at the audit and controls to see who entered something, accessed something. That's one thing, but it's another thing to show, hey, this is what happens to the pieces of the data along the flow. Prioritization is also important. So for those that know, FIFO is, right, first in, first out. So you can set prioritizers in NiFi as well. So again, this is just another piece, another tweak, another tune. We're not going to go into this as much, but I just wanted to show you that it is possible to do that when ordering does matter. Back pressure is incredibly important. If you don't set your back pressure thresholds, right? I mean, when you're first building a flow, it's not a big deal, but as you start to get into things much, much larger, I'm going to tell you a story of how one of our engineers took down an entire cluster because they decided that they wanted to do that split mechanism. And I told you, last resort to do a split. They split a flow file that actually had I think it was 100 or 200 million records in it. And they then kept doing different things in the split. And the thing is each one of those then shares the metadata, right? So all the attributes get split across every one of those flow files. One flow file becomes 100 million. The 100 million flow files start to back up because he didn't set his back pressure accordingly. All of that starts to happen and starts to consume heap. I mean, it just becomes a spiraling event of bad. And so, of course, getting the call at 3 a.m. that the cluster's down, and I go in and take a look at what happened, and I'm like, oh, this is bad. So back pressure will save you in some of those regards, right? If you actually set your back pressures appropriately, you can kind of throttle things before they hit a bad mark. And you'll see here, right? This is what bad looks like. It'll actually highlight red because this is only 10,000. But if you look at this, this is green because the threshold on this is much, much higher. Latency and throughput. So each processor has both latency and throughput. And you also see here, I have a little bit of, the run schedule, concurrent tasks, timer driven, all nodes. But you can actually set these parameters based upon how fast you need things to come out or, how correct they need to come. Do they need to come in order? So you can actually get a higher throughput, which means that you have a higher latency, or you can go lower latency, lower throughput, right? So you can kind of push this run duration the way that you want. And, like I said, there's a bunch of different knobs for you to tweak and tune within NiFi. And we discussed load balancing as well, right? So if you look here, right, you'll see that this is a round robin load balance configuration. Right. So if you look at this circle here, this little blue circle is actually showing you that I've made a load balance. It's very important to note because everyone makes this mistake, including myself. I made this mistake as well. When you want to load balance a flow, you load balance the flow one time. There is no need to load balance it after you've load balanced it once. What do I mean by that? Well, this generate flow file, this is starting at the beginning, and then I have this log attribute. If I were to have something after log attribute, let's say I want to do, update attribute. If I were to load balance between generate flow file log attribute and then do a load balance connection between log attribute and update attribute, what would end up happening is it would have to set that load balancing and kind of reshuffle the deck each time. When it's doing that, you lose a little bit of performance. If you do that across multiple processors within one flow, that's a lot of performance hit. There's no need for that. The minute you do this, what it does is it recognizes how the flow is. It takes a look across the nodes because it's round robin. It's basically just kind of pushing the flows. So if you have, say, 10 different files coming across on a 3-node cluster, it'll go file 1 goes 1 node, 2 goes 2 node, 3, and then 4, 5, 6, 7, 8, 9, and then 10, right? And so that's how they'll come across. Something like that. So you don't need to load balance it past that. It's already load balanced. So you just have to load balance once. Very important to note. So this is the security, and I'm not a security guru, I promise you. That's actually the weakest part of my engineering background is security. So I do apologize for that if there's a bunch of security questions. We do have Carolyn, who's pretty awesome at cybersecurity, so hopefully she can actually answer those if you do have those type of questions. But if you look here, everything is actually, you can configure TLS for NiFi, and by doing so, you actually have secure. NiFi also has something called site-to-site. It allows NiFi to communicate with remote process groups as well as other NiFi clusters. So what that allows you to do is essentially do a secure connection between two NiFi clusters, two NiFi nodes, a remote. So there's something called MiNiFi, and we won't get into that today. But MiNiFi is a NiFi agent that just sits on the edge, and you can communicate from that MiNiFi agent back to NiFi. So like say, for instance, you have laptops, servers, something in which you want to pull logs and push them over and not have NiFi connect to it, right? You only want one-way communication. You'll utilize that site-to-site to push the data back through. And then we also have, encryption at rest. So it's not permanent storage. So a lot of people are worried about the encryption at rest, but what ends up happening is that, NiFi in itself, it does have a little bit of storage, right? You have a content repository, a flow file repository, the provenance repository. So those are the repositories in which the data sits, but they don't sit there forever. So after, X amount of hours, depends on the configuration that you have, they'll start to fall off, whereas the flows actually make their way all the way through the life cycle and are no longer sitting on the cluster. They'll start to fall off as well. So NiFi is not about data storage, it's about data in motion and data in motion only. So building a flow, all right? Building a flow is relatively simple. And what you'll see here is that you have a bunch of different things. And in the demo, I'm gonna show you, you drag it down from the processor and drop it in. You'll see here that you have all the different groups associated with it, but there's a very easy to use, kind of a type ahead here where you put in generate, it gives you everything associated with it. If you were wanted to know something about AWS, it would give you things associated with the tag. If I were to put in SQL, it would do the same thing. But by bringing that down, essentially this drag here and drag it into the canvas, what'll end up happening is this will pop up, and then you'll be able to type it in and add your first processor. In the processor itself, you're going to see that there's multiple tabs. So one of them is for properties. The properties tab has a lot of different things that are configurable. If you notice here, we have a bunch of things that are, say, these bold type here. All the bold stuff you have to put in. You have to put parameters in for the bold stuff. For the stuff that's not bold, it's optional. And then once you configure the processor, it's time to connect it. So you'll see that this is an outbound connection only. So generate flow file. I do have one of those to show you as part of the demo. And then, so publish Kafka, I want to do something after publish Kafka, but you're going to see here that I have both an inbound and an outbound flow file that's kicking through. You can also schedule. So I have a lot of processors that I only want to run once. And what I do is I do the scheduling of, say, like 10,000 or something like that. I usually do this for development purposes, 10,000 seconds. But in part of the scheduling, I can actually do a run schedule, which you'll see here. Run one, it's every 10 seconds. And what I don't show you is that there's also a cron scheduler. So if you're running batch jobs, you can actually set a cron scheduler. I want this to go off every day at midnight. Very easy to do. I set up flows like that all the time. We actually had a lot of batch jobs that would run. And when you're working in enterprise, you have usually like a window from like, say 11 p.m. to 5 a.m. to get all of your work done for all those batch jobs. So we would run the batch jobs and we would stagger them based upon what we needed. But very easy to do with that. There's also the thing called queues. So we talked about these queues. We talked about setting back pressure thresholds. So here's the back pressure threshold here. You can do it based upon the number of objects, which is the number of flow files that come in, or the size. And you'll see this is where you also can set your prioritizers as well as your load balancing of connections. Now, when we completed the flow for our published Kafka, and you'll see in this event, right, this is something that it looks like. If you see these things here, these are funnels, right? These little square boxes are called funnels. I use them all the time when I develop, and here's why. If something fails, I don't want to have to go replay an event, especially if I'm going after a server, if I'm going after an API. I want to be able to actually just maintain that flow file that failed, figure out why it failed, make the changes that I need to make change, and then route it back into itself. And I'll show you in a demo of how I do that. I'll have to get something to purposely fail. I think I can figure out how to do that. I'm usually good at breaking stuff. So what you're going to see is that, you know, you can route the failure to something, you can route the success to something. These are just in here as placeholders. Typically in an enterprise world, I would route failure to some sort of log message and then route it to, you know, a file system so that I never lose the data. I think that's the key, right? Other systems, other streaming, you know, components, you know, tools that you use, when something fails, you get a failure message, you get something, but then that's it. You then have to stop everything that you're doing. You have to fix it, and then you hope to replay the event. But you've lost the data that came in at that point in time, right? It reached a certain point, it failed off, you're done, you now stopped your processor. You don't have to do that with NiFi. I think that's the coolest part about NiFi. And you'll see this is just actually, this is another processor. This is the one that we use for Kafka. And you'll see you can put the Kafka broker, the type of security protocols. I actually have, we're using a brand new platform called CDP Public Cloud. Well, I guess it's a year and a half old, so it's not brand new, but you know, I have a data hub in there which has NiFi running in it. So when it comes time for the demo, you'll actually be able to see exactly what I'm talking about the configuration aspect of some of the processors. And over here, so there's two ways that you can start and stop a processor, right? You can start a processor here, you can stop a processor here, you can start and stop an entire group of processors over here. You can also just right click, and then in the drop down of the right click, it says start, stop, disable. There's a couple different things you have. You'll also see that these little pieces here, this is to upload a template. So NiFi believes in things called templates. Eventually they're going to go away because you're going to be able to import flows via JSON. But you know, to give you an idea, if I were to show you my local cluster, I think I have something like, you know, 110 different flows on my MacBook. And a lot of times I'll leave them there. And if I need to do a demo like I have to do today, I will just take the template, upload it into the new system, change the parameters that I need. You know, most of the time I use parameter context, which we'll go into as well in the flow. And then all you need to do is set those parameter values, and that way you're not replaying everything and having to redo it all the time. So the NiFi registry, right? It allows you to do what we call the flow development lifecycle. So only a few years ago, I guess, it was really developed and brought about, but the NiFi registry allows you to make changes to the flow and do version control. And what I did is I have 5 different flows that are available. 2 of them I've actually version controlled and set them to their own buckets. The other 3 I did not, because what I want to do is I want to actually show you that I'm going to make a change to one of the flows and what it does with the change. It'll actually make you aware, but then I could revert back versions if I want. So you have the capability to make a change. If something goes wrong, revert back quickly to the latest version, but it'll still maintain. And what it does is it lets you know that, hey, this version is a version behind, this version is the latest version, or someone made a change, but they never actually updated the version based on the change. So they never committed the change to a new version. So the processor group, right? If you see this processor group here, right, this little check mark, that means everything is good to go. You're going to see like a little, what looks like an asterisk almost. The asterisk means that someone made a change to the flow and that the flow has not been committed yet. That change has not been committed yet. And then the other thing that you'll see is that there'll be a red mark as well. And the red mark will tell you, hey, there's a newer version available. So you'll see this when you go up a version and then you go down a version because something went wrong. So the registry structure is like this, right? So you have essentially a bunch of buckets. And what you're going to do is you're going to take your process groups and you'll assign them to a bucket. And that bucket is the thing that maintains all of the backend data of where things are being stored. So you can have multiple versions that exist within the same bucket. You can then have a process group that have process groups underneath of it, so on and so forth. Anything that's contained in that parent process group that's been version controlled is, again, part of that entire bucket. So you can think of it like a snapshot, right, of the configuration. And it's basically maintaining all of that in the backend in the NiFi registry, which is very important for this, right? So the current way, if you wanted to say you're in an enterprise world and you want to do code promotion from dev to test to prod, you would have one NiFi registry that sits at the top. And what you would do is you would actually be able to do through the API calls, or you can use CI/CD tools like Jenkins to actually move the flow, right? So you make the change in dev, the version, then commit it to QA, then commit it to prod. So you can actually do the full development lifecycle of the entire flow. And you'll see this is very, you know, this gives you an idea of the different tools you can use. And I got to give a huge shout out to Dan Chaffleson, who wrote what's called the NiFi API, right? So the NiFi API is awesome. It allows you to use Python to be able to build flows like very easily and push the flows for commits. I actually used it quite a bit when I was at the water company, and I've used it even for some of our demonstrations. It's pretty amazing. Go check it out. It's definitely an awesome open source tool. Thanks, Dan, for committing that and keeping it up. And I know there's a lot of people in the community that still utilize it. So I'm going to stop there, right? And I want to see, you know, I want to, George, if you can bring Carolyn back on, that would be awesome, because I think maybe we have some questions, and if not, then we'll get into a demo. Carolyn, you're back. Where have you been?
I'm back and badder than ever. All right, so yeah, we do have some questions. This is good. So let me go back to my other window. So first of all, we have people from a lot of different places that are listening in to the meetup. We've got folks from Massachusetts. We've got Ashwin and Augusto from Mexico City. We've got Greg from Princeton, New Jersey. Tempo from France. Bhaskaran from Austin. And we have Han Yin from New Jersey and George from Philly. And we've got Ashkander from Chennai, India. And we have, I'm going to butcher this name, I'm sorry. Abdulali from Morocco. And R-Menzer75 from Chile. So we have people from practically every continent. This is exciting. This is exciting stuff. But we do have some questions as well. So Ashwin would like to know, is the primary use case for offline data ETL? Is it good for real-time processing also? And can you ensure good SLAs with Kubernetes and be horizontally scalable for real-time? So. Yeah,
so, okay. That's like 5 questions. So let's take the first one.
I know I've done a few of these Hello Series meetups, and some of the questions I just get I'm like, okay, are these people really like rookies at this stuff? But anyways, so yeah, so question about scalability.
So let's go to the ETL thing first, right? So can it do ETL? Yes. The T is dependent, right? So ELT, ETL, when you think of a transform, right? NiFi does have its limitations when you need to do like joins of data sets, especially window joins. I would push someone towards something like Flink for that style use case. But if you're doing transforms, like you have XML files that you need to convert into some sort of file format, or you want to put it into, say, like, obviously we're going to talk more about Hive and Impala, right? So you want to convert it to ORC or Parquet format, and one of the big data formats, or you want to move it to Avro because you want to push it into Kafka. Any of those things, definitely NiFi is there for. Real-time ingest, yes. SLAs, depends. Have to find out really what your SLA is. NiFi is pretty much real-time, near real-time, but real-time is really a definition by the user. I would say if you're a bank and you need sub-millisecond latency, depending on what it is, I'd probably push it towards Flink. But if NiFi, depending on the use case, NiFi will handle mostly 80%, 90% of the stuff that you need to do. There's always going to be edge cases that it doesn't handle well. So for scalability on Kubernetes, so NiFi on Kubernetes itself, it is available. There have been people that have built their own operators. We have just come out with NiFi on Kubernetes, which we call the data flow experience. I'm not going to be going into that much here, but again, yes, for the SLAs, depending, right? So, I would say that if you gave us an idea of your SLAs, we'd have to take a look at the cluster, but scalability within that cluster is going to change a little bit based upon that. Did I answer all 5 pieces, or?
I think so. Yeah, I think you got them all.
Anything to add, Carolyn? By the way, Carolyn's awesome with streaming too. So it's not like I'm the only one here.
So I'm gonna say that NiFi's real wheelhouse, right? So any of these tools that you're using can be used to do practically anything, right? So sometimes you'll see some kind of wacky, it's like, wow, they used Hive for that, or they used HBase for this, or, but the real wheelhouse for NiFi is data movement, and especially when you have data that's moving across networks, right? That could potentially go down, right? So, you've got connected devices and they're coming through a network that's maybe spotty. You have remote devices, or if you have medical devices or IoT, it's really great for those kinds of applications. Whenever you have to move data across regional data centers, I've got a whole bunch of data that I'm going to push into a central data store. It's really good for making, those transformations before they go someplace else and kind of, I want to route this over here and that over there. So it's really good for those kinds of use cases. Flink really excels when you start to get to streaming analytics. So, for example, I do cybersecurity, and we use NiFi extensively, right? So logs they're in like every nook and cranny of the enterprise. And we kind of, scoop those all out, put them in through NiFi, and then send them into Kafka. And then we pick them up with Flink, and we do processing that you would look at as more like complex analytics or complex event processing. So I get events, and I want to say, okay, did I get like 3 of these within the like John was talking about with the windowing. So anytime you have to do things with windowing, you have to do a lot of enrichment or kind of just a general like processing of the data engineering. Those are all really good applications for Flink. So it's not really NiFi or Kafka or Flink. They all kind of go together, and they work hand in hand to bring together a solution. And so Tim Spann has this thing, he calls it the flank stack, right? So that's where it all comes in, and they're all friends, right? It's not NiFi or Kafka or Flink. It's them all together. So.
Yeah, I completely agree. And by the way, if you've never looked up Tim Spann, SPANN, so there's 2 N's, Google him and go look at his Flink stack. The dude does some awesome stuff with NiFi, Flink, Kafka, all kinds of tools. So he's kind of the streaming guru. Very good friend too. Any other questions, Carolyn?
Yeah, so we have a question about load balancing. So what happens when you have a processing that's going on one node, the node goes down, what happens to it?
So if each processor itself actually has the capability to run on all nodes or a primary node. So you'll see in the configuration, I'll set that. If you set your parameter on the node, right? So if you set the configuration on the processor, I'm sorry, to just go on primary node, if the primary node goes down, you have to wait for the primary node to come back up, and then it can begin processing. So what you'll see is, like, a lot of times there's specific processors that will give you, say, duplicates of data, right? You do a list file processor. You really want to run that only on a primary node. Then every other processor that runs after that will be on all nodes. And what ends up happening is that if they're set on all nodes, if one of the nodes falls off, it'll just continue processing on a different node. So you don't really have to worry about that as much. But if you set everything to exist on a primary node, well, then you might have problems, or you might have to wait. And this is why we recommend, by the way, like for lower environments, a lot of people want to just do one NiFi node on a lower environment. 2 is the minimum on a lower environment. And the reason being is because they set up things and they don't realize they put everything on a primary node maybe. And when they go ahead and promote that flow to, say, a production environment that has multiple nodes, then what'll end up happening is that you just are, you either didn't set it up right, or the other way around too, where you set it to go across all of them, and then it's using something like a list file processor, and now you get copies of the data. So, setting up your flows and setting up each processor correctly really is helpful. Anything to add,
I think that's great advice. Yeah, I think that's great advice as well. So especially you want to be able to test the properties of your NiFi. So you want to say, oh, what happens when a node goes down, right? Well, you can't go do that in production because you don't want to start shutting things down in production. But if you have a test environment, you can do that. And you can say, okay, part of my test plan is going to be, I'm going to run this flow. I'm going to send in my synthetic data or my test data. And then I'm going to shut this node down. I'm going to see what happens. So it's really important to have your lower environments be somewhat similar to the characteristics of your production environment so that you can really assess how things are going to work.
Yeah, I agree.
All right, great. So that question was from Adhish Kandar from Chennai, India. So the next question is from MC Cat from not applicable. I don't have MC Cat's NC Cat's location, but would like to know about some examples of ETL with NiFi.
So where I came from, and you can Google it, it's called Bridging the Gap, and then SAP. We actually built flows to do incremental batch, which is not true change data capture from SAP. And we actually made it so that the job that we ran had to make sure that, as it was pulling data from SAP and then pushing it down into, Hive, essentially, right? We would do merge operations in that workflow, right? So, or the NiFi flow. We actually would push it down to a staging table, and it was an HDFS, put it in HDFS, you have an external table that sits on top, and then we would build a merge command to basically replace the text into it. That would merge the data into the base table into Hive, and then once that was done, it went down into essentially a collector. It counted. It needed to have this one job actually needed to have 10 different things to trigger before, for it to go ahead and pull the rest of the data. It was a Spark job. So what we did is we actually had all of them route down. When the counters hit, it would then hit down. It knew it got a flow file from each one. It would then trigger the job. The job would do the pull of the joins that it had and then push it off somewhere else. So that was rather complex. That's actually, we built an entire mechanism. And matter of fact, big shout out to Nagaraj Kumar and Yogesh Prabhu. Yogesh, I forget your last name. Sorry, man. But they actually built a framework as part of that called NiFi Flow as a Service. So if you look up Naga on GitHub, you'll see that it's in there. But essentially, a way to go ahead and get that data out of SAP and automatically build the NiFi flows, the Hive tables, all of that stuff. it's pretty awesome. So any examples that you have of a ETL process that you've done in NiFi, Carolyn?
I try not to do ETL.
She's not, Carolyn's all about logs, man. She's the log data queen. So
no, I just have like bad flashbacks because I spent a lot of time doing ETL jobs in a previous life, and I'm like, if I never do ETL again, it'll be okay.
I don't blame you. It's not my favorite thing to do either, but that's one example.
I have scars. I have scars to prove it.
So do I, right?
Yeah, for sure. So Augusto is asking about reusable NiFi flows. So how do you reuse NiFi flows? And if you have like different source and destinations and configurations, how do you reuse them?
So one, parameter contexts are always good, right? And you can set the parameter context based on the processor group level, and you can make different changes based upon that. Reusing flows, like right now there's templates, and with eventually templates are going to go away, and you're going to get actually a JSON essentially of the flow file itself, right, or the whole build. So as NiFi progresses, you'll eventually see templates kind of get deprecated, right? And you'll actually have the flow definition templates that will come in that are not the same XML templates that you have today. But using things like parameter contexts allow you to kind of either change environments and then have those environment variables different. You can use files sometimes that contain environment variables, or the different variables that you want with the parameter context. And I'm going to show you a parameter context and how it works as part of the demonstration as well. Anything that you think to add to that, Carolyn?
No, I think it's pretty useful. Being able to parameterize the flows is a huge win. Using the NiFi registry also as well. So
yeah. And you'll see things like XML, so you're going to need XML files to write to HDFS. You're going to need an HDFS pathway, right? Those things are very good to parameterize, right? And I do, and you'll see that.
All right, cool. Adhishkander would like to know about scheduling with cron, scheduling to run SFTP processor every 10 seconds for 2 hours, and then asking about the cron value and whether it can be parameterized. I don't know. I think we'll have to come back to that one. I'm going to have to read through the question.
Yeah, so one.
Not quite sure about that one.
For the cron value, I don't think cron values can be parameterized, although I'll definitely check, because I'm actually looking right now to see. You would set it up as part of the run schedule, and you really wouldn't do that. You don't use the typical Linux cron, but you could definitely set it up to do every 10 seconds. I don't believe that they're parameterized, the scheduler, the internal pieces yet. So.
All right. A question from Tempo in France. And I love this question. It's about UML. I spent a long time working at a company that did UML. And I come from a software engineering background, software engineering diagram background. So Tempo would like to know, is there a normalized language for the diagram like UML?
I'm going to let you answer because you like that question so much.
So the diagrams themselves are essentially a visual of a software process flow, right? So there are rules and there is language, like there's a regular expression language inside of the configurations. So there is basically it's a higher level of 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 structure, right, around a flow and around these processes. So definitely it is an abstraction like UML is. The 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 purpose of the diagrams is a little bit different, right? So UML is about defining the structure, the classes, the relationships, the data, right, and the state models and flowcharts of a complete software application. This is a different kind of language, which is a flow based, and it's more procedural. But it's a similar idea, right? It's a similar idea. It's a high level language that describes a software design and a software process.
You know, it's funny. I never thought about a NiFi flow as a UML, but now that you say it, I mean, it's basically it, right? Like you have each processor could be like, you know, your box essentially, and inside you have attributes associated with it, which are variables, right? Different things. And the relationship connection could be through whether it's a retry or a fail or a success queue or whatever, right? And it's the same way to have, you know, inherits or, you know, an abstraction. Yeah, that's pretty cool. I didn't think about that. That's why I let you answer it, not me.
Probably the closest thing would be a state model. Probably is the closest thing that you would have in UML. All right, great questions. Blast from the past there. Okay, so we have quite a few more questions. Do you want to do some demo and then handle some more questions, or what do you want to do?
I think that's a good idea. I think we should go over to a demo a little bit. More questions will pop in, and then we'll just keep going with the questions when we get back, right? So you guys can see my screen, right? And what I'm showing you here is just my NiFi canvas, right? So I have this in our CDP public cloud, and you're going to see, like I said, I have 5 different process groups here. So the first one is, and we'll go into this, right? This is just a generate flow file processor. If I come into configuration of this processor, I have this run schedule to run every 100 seconds. Why do I do that? Because I don't want to have a million things coming in. You're going to see one where I'm going to set it at 0 because it's a stateful process, and I'm going to actually push data into Hive and then actually read it back out. As you see here, as part of the scheduling, remember I talked about primary node versus all nodes, right? So if this is running right now on all nodes, which is fine, you can set your concurrent tasks within the processor, but please realize that more concurrent tasks does not mean better, right? You can actually, you have a thread pool that exists, a global thread pool that exists within the cluster itself for each node. And then you have each one of those processors can take up a concurrent task or a thread within it, right? If you're exceeding, like, say, 10 to 12, you know, concurrent tasks within a processor, then there's probably something wrong with the flow design. You should probably rethink what you're doing and reset, right? Mark Payne has an entire series, I think it's 4 videos so far, on, you know, correcting bad flow design, right? What we call flow smell, right? Like same thing with code smell. So he actually goes through those in those 4 videos, and one of them he talks about, you know, concurrency and threads within different process groups. In this property, all I'm doing is showing you a way that I can kind of change the data set a little bit. I just put in something which includes like a null value here and a null value there and nothing there. Right? And this is just would be interpreted as a CSV. So I'm going to go ahead and start that, and you're going to see that because I set that on all nodes, generate flow file, I get 3 copies of it, right? Now, just to prove to you about the 3 copies versus 1 copy, I'm going to come here to primary node. I'm going to go in here, and I'm going to empty this queue, which means that I'm going to delete all of the stuff. It's important to note that when you need to empty a queue, stop the processors around it. So that way it empties. If the downstream processor is actually still started or the upstream, then what you'll get is that you're not able to empty the queue completely. Now you'll notice that I have a little p here, right? And this little p here means that I'm running on the primary node only. So I'm going to start this one again, and instead of seeing 3 flow files, you notice now you only see 1, right? So I'm just going to go ahead and stop that because we're doing this piece by piece. So there's a convert record processor here that's using a CSV reader and a CSV writer. These are called controller services. So if I go in and I go ahead and I press this arrow, it's going to take me to a list of controller services that are available for this cluster. The controller service is a reusable component. So if you have a database to connect to, or if you have a reader or a writer to connect to, or if you have a schema registry to connect to, all of these things will be a controller service. They're reusable components across your entire cluster. However, it's very important to note the scope. Reason being is that if you create a controller service on the very top level, what we call the root canvas of NiFi, it can be used by any underlying canvas. So each time you go into a process group, you're going to see down here on the right-hand corner, and we won't get there yet, you're going to see the breadcrumb trail from process group to process group. If I create a controller service within the process group, then it can only be used by that process group and any process group underneath of it. It can't be used by another process group within the same root canvas. For this reader, all I'm doing is I'm inheriting the schema. So it infers the schema. How awesome is that, right? So there's sometimes in processes, you don't really know what the schema is yet. You want to get the data in. And so what you do is you infer the schema, you take a look at it, and it'll actually give you, hey, you know, convert it from this to this. In this case, we're just doing a record reader and writer. And if you see here, the minute I closed the controller service, because I actually created that controller service on the root canvas, what'll end up happening is it takes me back to the root canvas, right? And you'll see here this NiFi flow. Also, we talked about the registry. We won't get into it yet. We'll get into it in a little bit, but as you notice, look at the top corner of my processor. I changed it from all nodes to primary node, and by doing so, I changed the underlying flow. This is basically telling me local changes have been made. They have not been committed yet. So before we get going, I'm just going to go ahead and commit this local change and change to primary. And I'm going to go ahead and press save, and it goes to a green check mark. And now if I want to go ahead and change the version, I could go back to version 1 if I wanted to. We're not going to because we want to keep it the same. So back in the flow, all this convert record's really doing is just making it from a CSV reader to record set writer. There's not really much going on. There's other ones that I'm going to show you where I actually do something very important. So we just do that. And then this replace text processor, what it's doing is it's doing a literal replace. It's looking for a value like this. And it's essentially saying, hey, if it has that value, I want to replace it with a binary, right? So I'm going to go ahead and start this up. And you're going to see here in the success queue, if I go ahead and list the queue, remember we talked about the capability to see the different things within the flow. If I hit this I button over here, you're going to see there's details associated with it. So I can go into the attributes and figure out what's the file name. So this is a unique file name that's given to the flow file itself. I can look at the MIME type. So it's a text CSV. I can look at the record count, right? Because there's 3 records in it, and it gives me the UUID. So it gives me all of that information right then and there. If I come back to details and I want to view it, you're going to see this is the original, right? So I can format it if you have it in a different type of format. You're going to see every place, right? And this is part of the reason why I did the CSV record reader. What I did is I wanted to show that if I had white space or if I didn't have white space, that white space would be taken care of by the record reader. And then the replace text processor comes in and says, hey, I'm doing a literal replace. If I have these 2 things together, I can go ahead and change the value. Place text processors are actually pretty, they're pretty useful. There have been a lot of processors that have allowed you to either update records now, so you can actually make a change to a path within the record and have everything go in. Pretty awesome. But to me, this is the first development flow, right? And if you notice here, I have this down to a funnel because I don't really want to do anything with this data. This is just my first flow that I built. Not really a big deal. So I'm going to go ahead and empty this queue so that data is just not sitting there. Press OK. Now, the first thing everyone wants to do is they want to ingest a file, right, from some sort of file system. So here we go. Let me silence my notifications here on Slack. But what you want to do is you want to go ahead and you want to go ahead and, ooh, I guess that went a little too wrong way. You want to go ahead and make sure that you either list the file and then fetch the file. And the reason why I want to do this, and you're going to see here, is the list fetch actually gives you the capability to have a state. So you'll see here that I have a listing state. And what I'm going to do in this case is I'm going to go ahead and clear this state because I want to pull this file again. Now, the list file, let's go in and take a look at the configuration. I essentially have a CSV file that we call sales, right? It's not real, it's fake data. I have the tracking timestamps. I have the location for the directory is local. I can also make it remote if I wanted to. And then I have a file filter. There's no file filter right now, but let's say I have a file system and I want to only pull only the CSVs, right? So there's, say, like mixed file formats, or sometimes older mainframe systems, you'll have files, you'll have copybooks, right? You don't want to take the copybook, but you want to take the file. So you want to pull that in. You can actually filter that out right then and there. What this does, and I'm going to stop the fetch file, is this actually kind of builds a pull path for you. And now what you're going to notice is I have one successful flow. If I go back to state, you're going to see that I now have an epoch timestamp, right, associated with that pull. When's the last time you pulled the data? So this is very important for SFTP processors, right? Any of the list processors for list HDFS, list files, list FTPs, SFTPs, any of them, you want to make sure that you're not pulling the same data twice. So by using a get file processor, you don't have that capability. But the list file, because it's stateful, you do. Let's go ahead and close that. So you're going to see here, if I come in here to the list queue, I take a look. There's no data here because all it's doing is feeding the metadata over. If I come to the attributes, you're going to see that I have the absolute path. It's going to go ahead. And you notice that this is the file that it's going to pull. So I didn't put that in there. If I had 3 files, then I'd have 3 flow files from list file, because it would then map each one and say, this is the file I want you to go get, right? So now I'm going to actually go to the fetch file processor. So let's stop the update attribute. So we're going to go ahead and start this. And what you're going to see is now I have one file that's 5.95 megs. Great. What does that look like? Well, we know the file name is this salesrecords.csv, right? Because that's the thing that we actually pulled from the list file processor. If I go ahead and hit the I button, you'll see the file creation time. I have a little bit more metadata now associated with it. There's a UUID for the flow. If I come and look at the details and view the file itself, give it a second for the UI, because this is a relatively large file. It's over 5 megs. I'm hoping it loads in the UI. It might not. Somewhere in a couple of meg size, just a couple of gig size, you'll usually get it to load. I figure 5 megs shouldn't be that bad. But you'll see here at the very top are my headers for that file. You'll see here for the content type, it tells you it's a text or CSV. I'm not going to waste time with this. I can also download the file. So you'll see down here on the very bottom of my screen, I'm going to go ahead and download. And there's a CSV file. So not only do you have the capability to make changes to the flow or stop it midway, which you saw that I did. I stopped it, started another piece, one by one, I'm doing it. I also have the capability to download the flow somewhere in time, right? So if I went out and got data from an API and I'm like, I would really like a copy of that JSON because I want to play around with something. Maybe I want to do a jolt transform, which we're going to do soon, right? Then, you're able to do that. You're able to download the flow file. You have it on your local machine, very easy to do. Now, you can set the security parameters to be able to access things at the process group level. We're not going to go heavily into security right now. This is more of a 101. Security would be that enterprise level. But you can do it so that you can guarantee people aren't downloading flow files, right? That's one of the things that I wanted to bring up. This update attribute processor is actually, we were looking at, I was going to actually put it into Hive streaming. I decided not to do that, but this is just an artifact that's left over. This would actually look at the schema. So if I actually have a Hortonworks schema registry stood up, I'm not going to do that right now. But you'll see no harm, no foul. If I go ahead, it's just going to add that as now an attribute to the processor. I left it in there because I wanted to show you that this is what it does. So if I come in, there's a new attribute called schema.name, and then that's it. So like I said, I made changes to the flow before I committed it, decided to go a different route. I'm using this put ORC processor. And the reason why I'm doing that is that this put ORC processor is relatively new. You're going to see in another flow, what I do is I actually convert it to Avro, then use a convert Avro to ORC, and then I put HDFS. That used to be the old way to do it. You don't have to do it that way anymore. I have a CSV reader right here, right? I have a NiFi bucket. I have, Hadoop configuration resources. For this flow, I decided to show you how to type everything in. There's another flow I'm going to show you where I utilize parameter context, right? So if I go ahead and just start that up, you're going to see what it's doing. Oh, and I hit an error message. Oh, because a file with the same name already exists. I did this earlier today. So what I could do here, and it's always good to do things in the flow itself. NiFi has the capability to utilize what's called an expression language. You'll see here EL checkmark, param checkmark. That means this supports both a parameter context and an expression language, right? So what I'm doing is I'm taking file name, right? And I'm going to add the now to it. Actually, I'm not going to do that right now. We'll get into that in a little bit. But what I could do is I would be able to update the attribute on the fly, update the file name to actually have a timestamp associated with it and put that in. But because of time, we're gonna move on. So as I promised, this is my flow file for Philadelphia. And you'll see here, if I come in here and I take a look and I look at the parameters, from the process group, I actually have my core site path as a parameter, my HDFS as a parameter. I also have the Kafka brokers, which can be shared over here from the Kafka generator as a parameter. But I'm going to come in, and in this put HDFS processor, if I take a look at this configuration, you're going to see I just have parameter core site. So instead of having to type in all of that mess, because you saw what the other one looked like, it was relatively long. Every time I use core site, this is all I have to do. And I can use this for multiple process groups, right? So all of these parameters can exist. I can map them to whatever I need for the process groups, have the parameter context be different for each process group, but the parameters themselves can be shared across. And you're going to see here that I also have my HDFS path, and then I just use /Philly. So say, for instance, in HDFS, you want to do everything within like a certain context. So I created a raw and a weather path, right? I actually just did the raw and the weather. And so anything related to weather, if I wanted to do Philly, wanted to do another city, all I had to do was change this last piece here. And then it would be able to create that new file, put it into the new folder. So relatively easy. Now, let's start from the beginning. And I'm going to stop everything so we go through one by one. So let me make this bigger. Is this better to see? Yeah, I think that's better, right? So what I'm doing is I'm actually going into making an API call using an invoke HTTP processor. So if you see here, I'm just doing a get command, and this is the open weather map. And I am going to, at the end, take one of the cities that you guys gave us and on the fly, just change this, look at the code and then run it through. But I'm not going to push it in because I created a table off of this, and I'm going to show you what happens when I start this up and let it go. The scheduling right now is running on 1 second. And for these properties, what it's doing is it's going and looking at, I should probably make it a little less than 1 second, maybe every 2 seconds. Last time I did this, they removed my API key, right? Pretty easy to go. The API key, not a big deal. If you look at the run schedule, I'm going to set it at 2 seconds. I'm going to start this up, and you're going to see that what I get is one flow file response, 2, right? So it's bringing them in pretty quick, but I'm going to stop it momentarily. Look at the list queue of the processors. I want to look at the data, and you're going to see there's 40 different lists, right? So this list value here, there's 40 different things that come through. Well, if I wasn't lazy, and I am, then I should be able to just shift everything out with a jolt transform, but I didn't feel like doing that because I wanted to do it in 2 steps to show you exactly how it's done. And again, I'm lazy. So the first thing that I'm doing is what's called a jolt transform. If you've never seen a jolt transform, jolt is an incredibly powerful tool. If you really understand how to use it, you can actually shift things, you can pivot things, you can join them into new arrays. You can do a ton with, you know, essentially a JSON file using jolt. And this one, I'm doing something very easy. You're going to look here. I just have this operation shift. Ooh. This operation shift, right? And all I'm doing is I'm saying, get me everything with every value under list. That's it. What that does is it creates essentially this 0, 1, 2, 3. It'll create this top level of all 40 arrays. So 0 through 39 because it's 0 indexed, right? So let me go ahead and do that and show you. So go to this list queue here. And just as I promised, I have 0, and then I have a timestamp, the main, the weather, right? All of that. So I have all this data here. This is essentially all the data for Richmond or for Philadelphia, right? That existed based on these epoch timestamps. Well, that doesn't help me because what I want to do is I want to put this thing into HDFS. I want to make a table out of it. So the first thing I do is I split the JSON. Yes, I know I shouldn't split JSON. So I'm going to go ahead and start. And now I went from, remember I said there was 40 of them. I went from 3 to 120. 3 times a 40 is 120. Now I just have these individual records, right? But the individual records aren't ready for me yet. Because when I come in here and I take a look at the individual record, you're going to see, all right, well, I have this main that actually has all this stuff under it. And then weather is now an array with this stuff under it. And cloud has stuff. So I still have this, you know, embedded tree of JSON. So I need to flatten that out. So I'm going to use jolt one more time. Except this time I'm using a record-based processor. So NiFi uses record-based processors, which will allow you to take an entire record and do a transform across the entire record. This is probably less useful to show you because I'm doing an individual one at a time. But I'm showing you both. The jolt transform here doesn't use a record reader or writer. This jolt transform does. So no different than the one you had before, except now I have a JSON tree reader and a JSON writer. If I wanted to, I could actually change this from a JSON tree reader to a Avro record set writer and then merge the records based upon that. If you take a look at this, I keep doing that, man. If you take a look at this, you're going to see this is a little bit different than this is a little bit different than what I did before, right? This is actually just going to shift the data up. So I'm going to go ahead and cancel this. And I've done some pretty complex jolt transforms before. Matter of fact, it's one of my favorite things to do. And there's a jolt demo, a jolt transform demo that you can utilize. But remember how nested that record was. Let's go ahead and take a look at that record one more time. And now we actually look at it formatted and you'll see, all right, I have everything the way that I need it to be, right? Now I have a flat record, but I don't want to put that into HDFS as a single record because that's really, you're going to end up with a small file problem in Hive. It's a bad idea. So now I use what's called a merge record processor. Well, since I split the record initially, I'm using a defrag as this merge strategy, and I'm converting from JSON to Avro. So again, these are controller services reused. This is the same JSON tree reader I used over here. I can reuse the same one multiple times within the flow or anything underneath of it. You're going to see here that I have the minimum number of records is 40. So I'm waiting for all 40 records to come in for it to bin together and then push it down. So if I go ahead and start this, you're going to see I went from 120 now to 3. That's exactly what we want it to be, right? 120 to 3. So now it's merged our data into the flow file that we want. We have a 7 kilobyte file now, which by the way is still really small. And you're like, holy cow, what is that? Well, that's Avro. So Avro is a binary format. Yeah, but I don't know if anything worked. Did it work properly? Well, if you go up here to the view as and it says original, what you can do is you can go to formatted, and NiFi understands Avro. So now you'll actually see the data as you saw it when it was JSON content before you converted it over to Avro. So this is what the records look like. And as you see, it joined all 40 of them together. Very easy to go. And now I'm ready to put this into HDFS. But before I do so, I want to convert it to ORC format, which it's just a compression format that allows you to optimal row columnar is really what it stands for. It's a format that allows Hive to read relatively easy. And like I said, I showed you the parameters for the put HDFS, so we're going to go ahead and do that right now. Now, while that goes, I'm going to start this up, and I'm just going to let it run. It's going to run every 2 seconds. I'm going to come back over here, and you're going to see that I actually have a database ingest. This generate table fetch processor is using a Hive 3 connection pool, so I'm actually going against Hive 3, but you can use something like this, or you can use a database table record processor. So there's record processors that are stateful as well. I just did this to show you that if you want to pull data off a database and there's a timestamp component, right? And we did have a timestamp component because that data that's coming in, it's called DT, in the actual Hive table itself. You set a max value column, and that's what this thing is here. I can set the columns I want to return if I'm not doing a select star, or if I feel like the schema could change, what you can do is you can actually, explicitly state the columns that you want so that if the schema does change on the source system, it's not going to mess up your table, wherever you're pushing it into your sync, downstream. You can go ahead and take a look at it. You're going to see here I have a table name called Philly because this is just the Philly weather data. And the timestamp, if I come in and I take a look at the state, you're going to see earlier today, I actually did a query. So this is the epoch timestamp, right? But what this does is the generate table fetch just builds a query. And before I go ahead and do the select Hive QL, right? This is off of the old stuff. I'm going to go ahead and start this. And this is running like, I have it like, I think at 1,000 seconds. So you're only going to get one. But as soon as this data pulls in, what will end up happening is it comes in a success queue from the generate table fetch, and I'll be able to actually see the data that exists. And while that's happening, I'm going to go ahead and look at the list queue from earlier, but you're going to see I pulled data out of Hive. This was the data because it was in Avro format. That's what it comes out when it pulls off the database. This is the data that I had put into the system earlier. And you'll see like the timestamps are associated with probably, I think like 2 o'clock this afternoon, something like that, and you'll have like the different components, right? Temperature, it'll tell me whether it was raining or not. So it was raining this afternoon when I did this in Philly. I'm going to close that out. And we're going to go back and take a look at the flow right now. And you're going to see that this is successful, right? So I'm going to go ahead and stop this processor. It's going to give me a new one because it's running. And what this does is it actually builds a SQL query. It's going to say select star from Philly because I didn't name any columns, so it does the star. It's going to say where my timestamp is greater than the timestamp I had stored in the state system, less than the timestamp that is now. So essentially, go get me the data from this time to this time, and it's going to order, with a limit. You can put limit offsets in too if you want to separate it out. Shouldn't have a ton of files here. But what you're going to see now is I'm going to take this, I'm going to run it in the select Hive QL. This is going to take a little bit of time as well because I'm running off of a relatively small cluster. But doing things like this, I could increase the threads if I wanted to pull. It depends on the way the Hive theories are. I don't really have a validation query set up. I probably should. But all of this is an easy way to go ahead and pull in data in basically like near real time, right? Because it's pulling off a database. You don't really get database real time. And then I'm going to list this queue. I'm going to go ahead and take a look at, you see this one's 21 kilobytes because I'm kind of letting that thing run in the background. And it's adding more and more data. You go ahead and view this. And this is a lot more data than we had before, right? So very easy for me to put data into a database, very easy for me to take data out of a database, very easy for me to read data from a file, very easy for me to put data in a file. And the last thing that I want to show you, if we go back here, I'm going to go ahead and stop this flow. So I'm going to stop the whole flow here, is putting data in Kafka, right? So you can put data in and out of Kafka. This one, again, let me stop at all the pieces. This is a different API call. So someone created this random user API. I love it. It's an awesome generator. But what we're going to end up doing is, essentially get this data, and I'm going to do another Jolt transform. Again, it's a thing I love doing, and I'm going to create a customer record out of it, right? So this is a good way to generate fake data. Go ahead and stop that. You'll see about 6 of them came in. If I look at the response, you're going to see I get pretty awesome stuff. There's tons of data generators out there. So I recommend go ahead and looking at them through APIs, but you'll see I have, gender, name, location. This one, I only wanted to cherry pick some of the data. And that's the other thing that you can do with a Jolt transform is I'm doing a shift spec. Spec. It's every time that I try to grab my mouse doesn't like it. So you'll see here that I'm taking things and I'm actually shifting, I'm changing the name, right? So I can actually put name underscore and, so that what it's going to give me is name like first, name, last, right? Because in name, there's first name, middle name, last name. I'm saying, go get me all the data, right here. But I'm basically appending it so that I know it's name first, name last, so on and so forth, right? If I go ahead and start that, you're going to see there's all the records. You come in after the shift, and I have a nice flat record here, right, with all the things that I wanted. Last bit, I'm just updating an attribute because I'm using schema registry, right? So I have the schema.name there called customer login. I'm going to go ahead and start that. And you're going to see now all the data is in Kafka, right? You're like, oh, how do I trust that you're in Kafka? Well, I didn't want to show too much of the other stuff, but if I come to Streams Message Manager here, which helps you look at Kafka, I have the customer login data. I can come in and look at the data explorer and start to look at some of the data, right, associated with it. So now, I promised I would pick a city, right? So what we're going to do here is we're going to come in here, and what I do is I have for the API, it looks like I have a good list, right? So I wonder if I can, let me see. Chennai is pretty far, and there was lots of questions from Chennai. No, not in there. So how about Princeton? Let's see, Princeton, New Jersey. Okay, so I have Princeton, New Jersey. I'm going to come in here. I'm going to configure this. I'm going to change the API, the forecast ID here. And you're going to see as easy as it was, right? I now have a 15 kilobyte file. Actually, I got 2 of them. I'm going to go ahead and view it. And you're going to see right now in Princeton, it looks like it's cloudy. It's overcast. So whoever wrote from Princeton, I'm going to assume it's Tim Span. But whoever wrote from Princeton, I'm going to go ahead and say, is it cloudy out? Is open weather correct? But yeah, so that's pretty much it for the demonstration. I think we're going to bring Carolyn back, I'm hoping, and we're going to actually continue on with a little bit more questions, right? Carolyn, did you take a nice nap or no? Were you there the whole time?
No, I was just riveted on this NiFi stuff. So awesome. I'm learning stuff myself. So we are getting up to time here at 7:30. So I think we should do some raffle picking, and then this is George is probably gonna like kill me for this, but maybe we could do some raffle picking and then we take a few questions after.
I think that's a good idea, actually. What do you guys think, George? Yeah.
All right. So let's go ahead and we will do the raffle picking. And the winner is, I can't read it. Oh my God, I gotta make my screens bigger. Sorry. Wow, I really can't read it. Somebody help me out. Like I said, anything can happen. Oh, there it is. So we have Quinta King is the winner for package number 1. And who is package number 2? Ashwin Kumar. Ashwin, I think you should win the prize just because you asked so many questions. But thank you so much to everybody who joined in tonight. We had a great crowd and some really good questions. And we're just going to talk a little bit about how to get some other resources that you can look at in some of our next meetups. So you can see on the screen there, we have our resources, various parts of our website, and we will post these in the chat so that you'll have them ready. We also have our upcoming meetup on the 27th. I've got my information here. 28th. The 28th is going to be exploring data and creating interactive dashboards in the cloud, and that's going to be hosted by the Future of Data Austin. So I think that what we'll do is we'll come back with John and we'll take just a couple more questions, and then I think we'll wrap it up. So we've had a really great crowd tonight and a lot of questions. So that's really good. So quick question from Ashwin also about writing tests for custom Groovy code. So Groovy is like super useful in NiFi, and it's also really high performance. So I don't know, John, what do you suggest there?
I mean, there's I would say, I think Matt Burgess is probably working on something. Like I don't want to promise anything, but I'll have to get back to you on, doing like a proper testing. But, essentially with anything with the flow files, I think, putting it in and actually running it through is the best way to do it. But you want to test something, I think, even before you throw it in the flow. And that I don't know with the Groovy. I'll have to find out, right? Python's a little bit easier because, obviously I'm, there's many utilities. I'm more used to Python than Groovy, but we'll try to get you that answer. And
so what I did with this is I just opened up IDEA and I plopped my Groovy code into IDEA and I worked on it, and then I put it right back into the NiFi. And then of course you've got to test it again, right? Once it's in the NiFi to make sure that it works okay. But yeah, Matt is like Matt everything Groovy. he's like a Groovy master. So I always hit him up for questions with that.
I would say, I mean, like one thing, right? If you're doing it that way, just to know, right, that tests your function works appropriately, right? That you built in Groovy, but realize that there's flow file relationships. You have to have the IO, the inputs, Absolutely. Right? Like,
everything's got to be matching up. So you got to test it inside of the flow itself. But going into IDEA and testing it out in IDEA, it just I think it speeds up the process a little bit because you don't have to, you can use the syntax directed editor and you can kind of test it rapidly, quickly, and then put it once you've got it like pretty well vetted, you can put it in the NiFi flow after that and test it there.
Awesome.
I'm gonna say we still have quite a few questions here. I'm gonna take like maybe one more question, and then I think we're gonna wrap up because I don't and everybody hates it when we go over too much. So but as always, feel free to reach out to us over LinkedIn if you have questions. Also, you can also reach out to our Cloudera community, which is really useful. You can ask questions. You can get responses there from the community as well. So I think the last question we'll take is about there just were like a few questions about the failures, right? So for example, if a primary node goes down, what happens? Does another node get promoted? How does that work?
Yeah, so yes, that's exactly what happens. If the primary node falls off or it gets disconnected, even disconnected temporarily, what ends up happening is the cluster coordinator will assign a new primary node. So now one of the nodes that are up and standing will become the primary node. You can have a cluster coordinator both be a cluster coordinator and a primary node. And then if the primary node comes back online, right, or reattaches itself to the cluster, then it's now just part of the cluster again, right? So it can be utilized in those resources. So it's kind of like a self-healing type thing.
Yeah, so that's the purpose of the zookeeper. The zookeeper is keeping track of all of that and doing the failover and the leader election and all that zookeepery sort of stuff. It's pretty good stuff. So so thank you so much, John. This was awesome. So much stuff. I learned stuff myself. And
I have a question real quick before we go. Oh, you have a
question. Okay.
How many questions do we have left? Because if we're not answering them here, I want to answer them on either your Meetup page or my Meetup page or both, right? I want to actually get these questions answered.
Yeah, we get I don't know, probably like three or four, maybe 5 questions left. So
okay, all right. So how about this? For those of you who are left with us and we didn't answer your question, check next week. Join Carolyn's Meetup page or join my Meetup page if you haven't joined either, and we'll post the answers to those questions on both those pages. Okay, but I won't be able to do it until next week. So sometime next week, Carolyn and I'll get those answers to you, at least so you get your questions answered. And I know more meetups are coming. I know there's one in Austin, right? That's the next one.
Yep.
But
more meetups are coming.
But May 6th.
I think George. I think we lost John.
There you go. May 6th. I will be hosting a meetup with Tim Spann and Kenny Gorman. So with SQL Stream Builder, which is going to be awesome. It's a way to do streaming SQL using Flink and then essentially joining Kafka topics. So that's going to be awesome. It's a New York meetup, May 6th. But like we said, next one is in Austin. I think it's April 28th, right? You think that's the date?
Yep, 28th. So check the meetup page. Join in. We'd love to have you. We'd love to hear from so many folks from across the globe. This is sort of the good part about meetups being virtual is that anyone can join. And there's so many exciting things to learn about here. So just wanted to say thank you to everybody. Thank you to our social media staff, George and Shelby and Bill Brooks. And Bill, I'll have to say a special shout out to Bill because he keeps us all, he gets us going, right? He's like, okay, where's your copy? Where's your your page for the meetup? So Bill keeps us all on our toes, keeps the whole status running here. So awesome. Thank you, everyone. Thanks, John. And we look forward to seeing you soon at the next meetup. And this concludes our meetup.
Good night, guys.